Right. Then the different types of angles. If the angle is between 0 degrees to 90 degrees, it's more than 0 but less than 90. The angle is called as acute angle. And exactly 90 degrees, the angle is called as right angle. And if the angle is more than 90 degrees, but less than 180 degrees, then such angle is called as obtuse angle. Do you know this symbol which I am writing in the middle? This symbol. Heard about this?
Theta.
These are like X, Y denotes our variables. A, B, C, these things denote our constants. Like that. Particularly angles are denoted by theta, alpha, beta, gamma. The Greek alphabets denotes angles. And it's clearly, it's so clear to us. Why Greek alphabets for angles? Because angles are a part of geometry. And who invented and who developed this geometry? Egyptians. For them, what is the mother tongue? Greek. That's why all their alphabets used to be the variables. Like for us, X, Y, Z, A, B, C, alphabets. They use it for constants and variables because we are familiar with algebra. So if you observe all the algebra constants and algebra variables, they'll be English alphabets. Whereas angles, areas, if you remember, area of a triangle is denoted by delta. That's a delta is a Greek alphabet. Capital delta, this is small delta. Small delta is an angle. Capital delta is an area. So all these notations are coming from Greek alphabets because simple. They are coming from Greek alphabet because they are the people who developed the chapters. They are the people who mastered it. So for them, the language is Greek. That's why alphabets are Greek. Simple. Acute angle, obtuse angle, in between them, right angle. What happens if I cross 180? From 180 degrees to 360 degrees, reflex angle, and exactly 180 degrees, it's a straight angle, and one exactly equal to 360 degrees is a complete angle. Right? I think we stopped our discussion in the last class till here, right?
Yes, sir.
Right. Very good. Now, these are different types of angles based on the measure. Based on the formation, what are the different types of angles? And I'm sure this you know it from your 7th class. What are these complementary angles? The sum of measures of two angles equals to 90 degrees. Then the angles are said to be complementary angles. Can somebody tell me what are some examples of complementary angles?
+45.
Milan and Sahas, you can type yeah or no.
So 45 and 45.
45 and 45. Bhumika?
So 47 and 43.
47 degrees and 43 degrees.
90
Any two
degrees.
angles whose sum gives me 90 degrees. Such two angles are called as complementary angles. Are now trying to say something?
So 89 degree and 1 degree.
89 degrees and 1 degree are complementary angles. Now the advantage of these complementary angles is if you know one of them, you need not know the other one. The other is known to you. And the main fundamental diagram that you study with the complementary angles is a right angle triangle. Remember, in a right angle triangle, there are three angles out of which one is 90. I don't know the other angles. Say they are X and Y. But already one angle being 90, x plus y should always be 90 degrees. That means the two angles other than the right angle of a right angle triangle are always complementary angles. The very fundamental application where I use this complementary angles is in a right angle triangle. And the beauty is this is the triangle which you begin studying in the chapter called trigonometry when you start the next class. As somebody suggested, sine theta, cos theta, these are the words which come. There the basic triangle that you use is right angle triangle. And the basic property that you use is the other two angles other than the right angle of a right angle triangle are always complementary. If I know one of the angle, I will always know the other angle. Got it? Write down a small note here for complementary angles. Mention one or two examples, write the complementary angle definition, then I'll tell the note. First, write down complementary angles. Sahas, Milan, Bhumika, can we move ahead?
Yes, sir.
Write down one small note regarding complementary angles. In a right angle triangle, the pair of angles other than the right angle. The pair of angles other than the right angle are always complementary. Are always complementary. Right. There is one more such pair of angles, that is supplementary. When the sum of the measures of two angles is equal to 180 degrees, then the angles are said to be supplementary angles. Say 30 degrees, 50 degrees, sorry, 150 degrees, 20 degrees, 160 degrees, 90 degrees, 90 degrees. Add them. I'll always get 180 degrees. They are called supplementary angles. Can somebody tell me where do we use this word very frequently? What is the most familiar pair of supplementary angles?
The linear pair.
Linear pair of what? Okay, linear pair is always supplementary. Anything else that
Adjacent
strikes your mind?
angles.
Yeah or no?
Sir, the adjacent angles.
Adjacent angles of what?
Sir, in a transversal.
Okay, good. Okay. Heard about this word? I don't know whether circles is in 9th class or 10th class.
The
Take a
opposite
circle.
angles of a cyclic quadrilateral are 180 degree.
The sum of opposite angles will always be 180 degrees in a cyclic quadrilateral.
Yes, sir.
The pair of opposite angles will always be supplementary. You take any 4 points on a circle, join them, you will form a quadrilateral. In that quadrilateral, whatever the independent angles are, but if you add the opposite angles, the sum will always find 180 degrees. They are called supplementary angles, right? examples, not only numbers, you mention all this. Linear pair of angles are supplementary. Opposite angles in a cyclic quadrilateral are supplementary. The adjacent angles of a transversal are always supplementary. Mention the examples which are non-numericals also. Numerical examples will not give you the Sahas, but there should be only two angles whose sum is 180. It cannot be angles in a triangle. There are three angles are there. Three angles sum giving me 180. The angles will not be called supplementary. Only two. Understood?
Sir, what is cyclic quadrilateral?
Which is inside the circle, which is completely inscribed in a circle. That means you take a circle, join any 4 points. A quadrilateral inside a circle is called cyclic quadrilateral. Cyclic means on a circle. This pair of opposite will always be supplementary. Not only that pair, even the other pair also. A plus B will be 180. Similarly, X plus Y will be 180. So examples are pair of opposite angles in cyclic quadrilateral. Linear pair of angles. Similarly, adjacent angles by a transversal. These are all theoretical examples of supplementary angles. And now can we move ahead? Bhumika.
Yes, sir.
Yes, sir.
Adjacent angles having one common side and the angles lying on either side. Angles having the same vertex, common side, and which lie on the either side of opposite sides of the common side are called adjacent angles. Self-explanatory, just write the definition and the diagram. The most important thing here and which plays a major role is the common side. This side OB should be common vertex. And the two angles X and Y are lying on either side of the common side. They are called adjacent angles. So why I am using X and Y? I introduced the word alpha, beta, right? So angles should be in theta, alpha, beta. As somebody suggested just now, we used this as an example of supplementary angles. Two adjacent angles are said to be linear pair if they lie on the same straight line. What are the two adjacent angles here? X, Y. What is the common vertex? That was the common line. So X is lying on one side and Y is lying on the one side. But the end pairs, that is OB and OA, they are lying on a straight line. That's why such two pairs are called as linear pairs. They are adjacent angles and they are linear pair of angles because the two angles lie on the same straight line. And that's why they are called, X and Y are called supplementary angles because they lie on a straight line. Their sum will always form a straight angle. Can somebody suggest me what is the most familiar example of linear pair of angles? Bhumika? Arnav? Most general case of linear pair of angles. Yeah. Sahas, Milan, if you know, type. Meanwhile, Bhumika and Arno are thinking, what is a familiar pair of linear pair of angles? Milan, don't know.
The 90 degree.
No. Yeah, Bhumika.
The 90 degree and 90 degree.
Yeah, measures okay. Theoretical example. Remember these words? Exterior angle of a triangle and interior angle of a triangle. Not only triangle for that matter. Any polygon, the pair of at each vertex, the interior angle and the corresponding exterior angle will always be a linear pair of angles. Write on a small note or an example with theory, not the numerical. Numerical, anybody can create. And all the examples that you wrote for supplementary angles, measures will work here. So specifically for linear pair, theoretical example will be write down. In any polygon, the interior and the corresponding exterior angle. The corresponding exterior angle at any vertex is a linear pair of angles. Is a linear pair of angles. Okay, now listen to me carefully. I'm writing two statements on the board. Every linear pair of angles are supplementary. And second statement is every supplementary pair of angles are linear pair angles. Which is true, which is false? Or maybe both are true, I don't know. Is one true or false? If you can't speak, you can type. Is one true or false?
Sir, true.
What about two or no?
Sir, also true.
Two will not be true. There are many pairs of supplementary angles, like angles in a cyclic, opposite angles in a cyclic quadrilateral. They may not lie on the same line, but still their sum is 180. So supplementary angles doesn't mean linear pair angles, but linear pair of angles means they have to be supplementary. Clear? Bhumika.
Yes, sir.
Write down the statement. Every linear pair angles are supplementary angles, but not conversely. Every linear pair of angles are supplementary angles, but not conversely. That means every supplementary pair need not be linear pair.